Hello, everyone, and welcome to the Applications Manager free training series on application performance monitoring. So let's dive into today's agenda. So we'll be covering the topic in 4 parts. So in the first part, we'll discuss how to understand application performance using the APDEX course. In the second part, we'll explore how you can monitor code flows across your applications through distributed tracing. In the third part, we'll show you how you can pinpoint problematic elements directly within your application code. And finally, we'll visualize application architecture dependencies using the automated service map feature. Let's take a quick look at some recent insights from some trusted sources like IDC and Forrester. So according to IDC, 90% of respondents to a survey are currently using observability tools, helping administrators gain deeper insights and drill down into application data more efficiently. And additionally, a Forrester research report reveals that 87% of engineers believe that adopting a cloud-native architecture has increased the complexity of identifying and troubleshooting incidents. Before discussing the topics in today's agenda, let's start with why application performance monitoring is needed. So imagine a user accessing an e-commerce website, trying to make purchases from an online store. So after adding the required items to their cart, they proceed to place the order. But at the payment portal, they encounter some issues, like the portal taking a long time to load, or getting redirected to an unrelated page, or some error codes being displayed. So such disruptions can lead to a loss of potential customers and ultimately the loss of business. And meanwhile, the developers who are working on the application may struggle to identify the root cause of the issue. So as user demand for applications continue to rise, so do the complexity of application development. So that's why it's essential for developers to ensure that the website is bug-free, scalable, and capable of handling high loads, especially at the database level. So this will only deliver a smooth and reliable user experience. Let's look at some contemporary trends in application monitoring. So first, we have cloud-native applications. So today, many large-scale enterprises are moving their applications to the cloud. So cloud-native applications are scalable, flexible, and efficient, and they're built using modular components like microservices or containers, for example, Dockers or Kubernetes. So DevOps practices bring development and operations teams together for faster and more reliable software delivery. So monitoring cloud-native applications is critical to understanding how each component functions to ensure high performance and address issues under heavy user loads. So second is artificial intelligence for IT operations, or AIOps. So AI and machine learning are increasingly being used to enhance and automate IT operations. In the context of application performance monitoring, they help by detecting anomalies and unusual patterns, automating routine IT tasks, predicting potential failures using the historical data, and optimizing resource allocation for real-time performance scaling. So AIOps enables proactive user resolution, and it improves the overall application reliability. So third is user-centric monitoring. So this approach shifts the focus from traditional system metrics to the end-user experience. It tracks the user's journey from accessing the application all the way to task completion. And it monitors the metrics like page load times, response times, and overall responsiveness. So fourth, we have application observability. So observability goes beyond monitoring by providing deeper insights into application performance and health. So it involves tracking application transactions, trace logs, execution times, and other bottlenecks or error patterns. So observability allows teams to detect inefficiencies and resolve issues faster. And lastly, we have full stack performance monitoring. So this approach focuses on identifying and resolving performance issues across the entire technology stack, from the front-end interface to the back-end infrastructure. So it includes monitoring application code execution, server response times, database queries, and other key performance metrics like error rates and response times. So by collecting real-time data across all these layers, organizations gain a complete comprehensive view of their application health and performance. Let's explore the benefits of modern versus traditional approaches when it comes to building applications. So in traditional approaches, applications were hosted on-premise, with a single data center. So this often resulted in high downtime and limited availability, and that could lead to performance issues during high periods of traffic. So modern approaches leverage cloud computing and containerization to significantly improve availability. So features like load balancing, redundancy, automatic failover, and global distribution, they have minimized downtime, and they've enabled continuous deployment without disrupting the user experience. Also, scaling traditional applications involved purchasing additional hardware, which required substantial investments, and they also came with high maintenance costs due to the need for physical updates and repairs. So in contrast to that, cloud-based monitoring and infrastructure, they offer reduced upfront costs, efficient resource utilization, and horizontal scaling based on demand. So automation and containerization further contribute to operational cloud savings. Also, content delivery in traditional models was often restricted to a specific location or a data center. So that resulted in latency, slower performance for users in different regions. Whereas today, the use of content delivery networks, or CDNs, and edge computing, they ensure faster and more reliable content delivery on a global scale. So cloud services distribute content across multiple servers worldwide, reducing latency and improving performance across all the regions. And lastly, operational efficiency has also seen a major transformation. So managing traditional applications involved manual deployment, scaling, and maintenance processes, which lack the flexibility to adapt quickly to changing business needs. So modern DevOps practices like infrastructure as a code, continuous integration and deployment pipelines, and container orchestration tools helped automate these tasks. So this enhanced efficiency while enabling agility and scalability. And microservices architecture also further improves adaptability. So that allows for seamless updates without downtime and programmatic resource management. So far, we've discussed the importance of application performance monitoring with Applications Manager. So the performance monitoring feature, the core performance monitoring feature in Applications Manager is called APM Insight. So APM Insight helps you understand how your application behaves for end users across the globe by monitoring end-to-end transactions within your application stack. So if any performance issues are detected, APM Insight allows you to identify and troubleshoot them quickly, which enables faster root cause analysis and efficient first-level troubleshooting. So these are the supported technologies for APM Insights. It supports a wide range of technologies, including Java, Node.js, .NET Core, .NET, Ruby on Rails, Python, and PHP. So these integrations allow you to monitor diverse application environments with consistent visibility. Now let's look at the main factors that play a critical role in determining application performance. So first is response time. When a user initiates a transaction on a web application, the request travels from the application layer through the transaction and network layers, and it eventually reaches the application server. So once it's processed, the response is sent back to the user. So transaction response times refer to the total time taken from the initiation of the request to the receipt of the final response. Query response time, that's the time taken for database queries to execute and return results. So slow or unoptimized queries can significantly degrade application performance. And overall application response time, that includes processing time, network latency, and any additional delays. So second, we have application code. So bugs or inefficiencies in application code can lead to performance degradation, unexpected behavior or crashes, and excessive exception handling. So frequent exceptions may indicate the recurring issues that need attention. So when errors occur, stack traces provide insights into the sequence of function calls leading to the issues. So analyzing these stack traces can help identify and resolve performance bottlenecks in the code. Third, we have memory usage. So monitoring application memory usage is critical. So high memory consumption can lead to performance slowdowns or even application crashes. So if an application exhausts its allocated memory, it may become unresponsive. And this usually happens due to memory leaks, where the memory is not released properly and it builds up over time. So continuous monitoring helps detect and resolve these issues before they impact the end user experience. And lastly, we have slow database queries, database performance. So slow database queries can reduce overall application responsiveness. So long-running or inefficient queries can impact performance significantly. Reducing unnecessary or duplicate database calls can help speed up the application responsiveness. And query optimization and indexing strategies are key to improving database efficiency. So monitoring and optimizing these 4 factors: response time, application code, memory usage, and database performance, that's essential for maintaining a high-performing application. So now let's look at how APM Insight works. So APM Insight is an agent-based monitoring tool, agent-based tool designed to monitor application performance in real time. So the initial setup involves deploying an agent on the servers where your applications are running. So once it's installed, these agents begin collecting performance data and transmitting it to Applications Manager for centralized analysis. So within the application server, the agent uses a technique called bytecode instrumentation. So this allows it to trace individual user transactions as they flow through different layers of the application stack. So the transaction data is then sent to Applications Manager server at regular intervals, enabling detailed monitoring of application performance. So this helps identify bottlenecks or any performance degradation that occurs within the application. And APM Insight provides code-level visibility. So that allows teams to monitor slow-performing database queries, to analyze a real-time performance of real-time impact of the user applications, user interaction, and identify performance issues down to the method or function level. So this level of detail helps pinpoint exactly where in the code or in the infrastructure the problem lies. So users can also configure alerts and notifications based on predefined thresholds. So with metrics like response time, memory usage, or database latency, when they exceed the thresholds, the tool can trigger an alert to the IT or DevOps team. And that helps the team quickly identify performance issues and to investigate the problematic areas, such as code inefficiencies, slowdowns, or high page load times. And they can respond proactively to minimize downtime and to maintain a seamless user experience. Now let's look at how you can export and elevate application performance using the APM Insight Data Exporter. So the data exporter is a standalone component or a module within Applications Manager, which is responsible for collecting, processing, and transmitting application metrics and traces to the Applications Manager server. So its main purpose is to export the data collected by APM Insight, allowing for deeper analysis and improved visibility into application performance. So the data exporter runs as a separate and independent process, which means it functions autonomously from the other components or services within Applications Manager. So this separation ensures that the data collection and transmission process is efficient and it doesn't interfere with the other core monitoring functionalities. So its primary role is to handle and transmit application performance data, which is both metrics and traces, to the Applications Manager server. So metrics include key performance indicators like response time, error rates, and resource usage. And traces refer to the detailed execution flow of a transaction or a request within the application. So together, this information provides a comprehensive view of how the application is performing under various conditions. So a single instance of the Applications Manager data exporter can manage the data processing needs of multiple applications simultaneously. So this design makes the exporter highly scalable, supporting environments with numerous applications without requiring multiple deployments. So once the data is exported, it's sent back to the Applications Manager server, where it's analyzed to generate actionable insights into application performance, system behavior, or bottlenecks or anomalies in the transaction flows. So these insights help IT teams to make informed decisions, to fine-tune application behavior, and to enhance the user experience. So now let's look at how data flows through the APM Insight Data Exporter, particularly in environments using Python or PHP applications. So the data exporter supports application agents written in Python or PHP. So these agents are responsible for monitoring applications and capturing key performance metrics and traces. So to begin with, developers or IT teams integrate these supported agents into their respective Python or PHP applications. And once it's integrated, the agents collect performance data, including response times, execution traces, and other relevant metrics. And this data is continuously gathered from within the application as it runs. So a single instance of the data exporter is set up to handle data processing for multiple applications. And once it's deployed, it functions as an intermediate layer between the applications and the application manager server. So how it works is the applications continuously generate performance data. The embedded agents, the Python or PHP agents, can capture this data, and the data exporter aggregates, filters, and formats the collected data to meet applications managers' data structure and formatting requirements. So after processing this data, the data exporter establishes a connection with the applications manager server, and it then transmits the structured data for further analysis and storage. So this ensures that the data is consistently and efficiently delivered to the monitoring server without overloading the application or network. And once the APM server receives the data, it stores the information in a centralized repository. The data is then made available through the user interface for real-time monitoring and in-depth analysis. And this enables the system administrators, developers, and IT teams to monitor the health and performance of their applications, to identify bottlenecks or recurring performance issues, and to optimize the application behavior or user experience based on the actual transaction traces and metrics. So let's look at some advantages of using the data exporter. So using the APM data exporter, it brings several key benefits that help improve application performance, efficiency, and user satisfaction. So firstly, that would be the improved visibility of the APDEX score. So that's crucial for understanding and enhancing customer satisfaction. So a better APDEX score directly reflects how responsive and reliable your application is for end users. And you can also pre-analyze performance data to proactively identify potential issues, and that also enhances security. It also enhances network efficiency by reducing the data load transmitted directly from the application. It also supports preemptive alerting, notifying the development team before the performance issues escalate or before the application goes down. And you can also ensure customized data transmission within your infrastructure. So that helps the application compute more efficiently and scale based on performance requirements. So now let's explore some of the key performance indicators or KPIs in APM Insight. So first would be the APDEX score. So the APDEX or Application Performance Index score, it's a numerical measure of user satisfaction based on application responsiveness. So it helps quantify how well the application meets user expectations in a real-world scenario. So second would be response time. So this metric measures the average time it takes for the application to respond to a user request or a transaction. So lower response times indicate better performance and a better user experience. Third would be requests. So this represents the total number of requests made to the application within a specified time frame. So it helps assess the application usage and workload patterns. Next is data throughput. So throughput refers to the volume of data, usually in bytes, which is transferred or processed by the application over the network during the monitoring period. So it reflects the application's capability to handle large volumes of data efficiently. Lastly, we have exceptions. So this tracks the number of errors or failures that occur during the request processing. So these may include server errors, timeouts, 404 errors, or other issues that disrupt normal application behavior. So monitoring these exceptions can help identify and resolve recurring problems, which ensures application stability. So now let's understand the application performance using APDEX scores. So APDEX, like I mentioned, it stands for Application Performance Index. It's a standardized metric used to evaluate user satisfaction based on the responsiveness of the application. So it helps organizations understand how users perceive application performance and identify areas that need optimization. So there are three categories of the APDEX score. So the first category is satisfied. So this represents the best user experience. So the applications, it means that the application's response time is within the satisfied threshold or even better. And users in this category are typically content or happy with how the application performs. The second category is called tolerating. So this reflects a moderate user experience. So the response time is between the tolerating and satisfied thresholds. Users may accept the performance, but it's not really optimal or ideal. and continued operation at this level may affect user perception over a long period of time. So the third category is frustrated. So this indicates the poorest level of user experience, and the response time is worse than the tolerating threshold. And users in this category are likely to feel frustrated, leading to dissatisfaction or eventual drop-offs. So monitoring these APDEX scores is essential for understanding and maintaining application performance from the end user perspective. Let's look at how APDEX score is calculated. So the scores range from 0 to 1, where 1 indicates one indicates that all users are satisfied, and 0 indicates that no users are satisfied. So the APDEX score formula, it's the sum of the satisfied count and half of the count of the tolerating samples divided by the total number of samples collected during the transaction. So tracking the APDEX score helps teams quickly assess whether the users are satisfied, tolerating, or frustrated within the application. So it's a valuable metric for delivering consistent and high-quality user experiences. Let's look at the advantages of monitoring application performance with the APDEX score. So first would be user-centric performance measurement. So APDEX provides insights into how application performance directly affects the end-user experience. So this user-focused view allows the IT teams to prioritize improvements that have the greatest impact on customer satisfaction. Second would be it provides a simplified view of complex performance data. So APDEX condenses complex performance metrics into a single and standardized score, making it easier for stakeholders to quickly understand how an application is performing without digging through the detailed logs or charts. Third is benchmarking and comparative analysis. So with a unified scoring system like this, APDEX makes it easier to benchmark applications against each other. So you can quickly identify high-performing applications and drive consistent performance improvements across your infrastructure. The fourth would be a proactive user detection. So APDEX helps identify critical transactions with low scores, which can signal areas that need immediate optimization. So when performance dips below the acceptable levels, it flags the problematic transactions so that alerts can be triggered automatically. So lastly, we have historical performance analysis. So by tracking APDEX scores over time, IT teams can analyze performance patterns, identify recurring bottlenecks, and validate whether recent optimizations have improved user satisfaction. By now, you'd likely be interested in learning how to configure key business transactions to monitor the performance of your application. So in this part, we'll look at how you can identify and track the most important transactions within your application. So those that typically handle a large volume of user activity or are critical to your business operations. So all the transactions that take place in your application will be captured automatically. And from these, you can select the specific ones that you want to monitor more closely. So once selected, you can set defined thresholds based on the response time for these transactions. So that will help you detect any performance dips before they affect end users. So now let's look at how to track code flows across applications using distributed tracing. So in a microservices architecture, like the ones shown in this slide, it's essential to monitor the communication between multiple services or applications. So distributed tracing makes this possible by tracking the flow of a single transaction as it passes through different services. So here's how the tracking happens. So when an API request is initiated by one application to another, APM Insight automatically adds a HTTP header with metadata required to trace that request. So if the receiving application also has APM Insight enabled, it reads that header and processes the tracking data. So the trace continues as this application responds, or even when it calls additional services, the header and tracking information are passed along. So that allows you to follow the entire path of that original request across different services. So using this tracking data, you can see when the transaction was initiated, for how long each component took to respond, and which application and the transaction it was. So by expanding this view in the APM interface, you'll also be able to dive deeper into the method calls and code blocks that contributed to the transaction's overall response time. So this is particularly useful in identifying which part of the application or which specific service caused these delays. So now let's look at the auto-scaling feature in APM Insight. So auto-scaling is essentially an automated way to manage your application's resource usage. So think of a scenario where you have a cloud-hosted application or a website. So when there's a surge in user activity, your environment automatically scales up to handle the added load. So that creates new instances in the process. But once the activity reduces and scaling down occurs, so those extra instances may no longer be needed now. So but these instances will still remain in the system, unmonitored but consuming licenses, and that will eventually prevent new instances from being monitored even though they're active. So this is exactly the kind of issue that auto-scaling in APM Insight helps to resolve. So by enabling the auto-scale mode, used or idle instances, they're automatically unmonitored or deleted. So it ensures that you're only consuming licenses for resources that are actively in use. So with just a simple toggle to enable this feature, you can keep your resource usage optimized and you can avoid unnecessary license consumption. Moving on, let's talk about the importance of identifying problems within your application's code. So every time an error occurs in a Java application, the stack trace provides a snapshot of how the application moved through its execution until that point. So with APM Insight, when an exception is thrown, the stack trace is logged and it's made accessible. So this gives developers a clear view of the exact line of code that caused the issue, as well as the sequence of functions that led to it. So this visibility into the stack trace can be incredibly useful. So it allows your development teams to quickly identify the root cause of a problem and make the necessary code optimizations or bug fixes. More. So if you're working with Java-based applications, context-based monitoring offers an even deeper level of performance insight. So normally when multiple Java applications are running on the same application server, their transaction data is grouped together under a single web transactions tab. So this makes it harder to differentiate how each individual application is performing. So, but with context-based monitoring, you can separate and monitor each Java application individually, even if they share the same server. For example, let's say you have 3 Java applications running on a Tomcat server, a JPEG store, a sample web page, and a store sample. So without context-based monitoring, their data would appear collectively. But once you enable this feature, you'll be able to track each of them separately. So that means you'll get clearer insights, better performance analysis, and the ability to pinpoint issues or optimize behavior specific to each application. So moving further, APM Insight also brings the power of RUM analytics. So real user monitoring, or RUM, it gives you a real-time window into how users are interacting with your application. So at the front-end level, it captures key metrics like response times, page views, and JavaScript errors, and even performance trends based on geography. So this means that you get a clear view of how your application is performing across different devices, browsers, and locations. So when users face slow pages or errors, RUM helps pinpoint exactly where things are going wrong, whether it's a specific region, a type of device, or even a particular browser. And because all of this is happening in real time, it allows your team to make proactive improvements and fine-tune the application for a smoother and more consistent user experience. So in addition to that, Applications Manager also includes an application dashboard that ties all of this together. So the dashboard combines data from the APM Insight and RUM into a single and unified view. So instead of switching between the tools, your IT teams can monitor everything from one place. So the backend performance as well as a real user experience. So the dashboard offers a quick glance at important metrics like APDEX scores, active user sessions, failed requests, slow transactions, and even error reports. And on top of that, it also gives you these geographical insights to help you understand how your application performs across different regions. So this makes it easier to spot regional slowdowns or any localized issues before they impact a broader audience. Next up, we've also made improvements to the onboarding experience as well. So the Add Monitor page in APM Insight has been revamped to make it more streamlined and intuitive. So with this new step-by-step guided flow, setting up APM Insight monitoring in Applications Manager becomes much more user-friendly. So it's now easier to get started, to configure the necessary details, and to begin monitoring your applications right away without getting overwhelmed by too many settings all at once. On top of that, we've also introduced something called instance level alarm metrics. So this enhancement gives you a more detailed and granular view of granular level of control when it comes to performance monitoring. So you can now choose a specific monitor instance, and you can set thresholds based on the key performance attributes at that level. So if there's an issue brewing in just one instance, you'll know right away. So by setting alarms on these instance level indicators, your teams can respond faster, you can detect anomalies early, and optimize application behavior before users start to feel the impact. So lastly, let's talk about something that really helps visualize and manage application complexity, which is the service map. So a service map gives you a complete picture of how your applications are structured and how they connect with the other services that they depend on. So it's like looking at your entire application ecosystem from above, helping you understand how everything is wired together. So this map becomes really useful if you want to quickly check the status of different application components and their instances, to monitor essential metrics like response time, throughput, and connection status, to detect and resolve application issues before they affect end users, and also track failed request counts so you know exactly where something's going wrong. So there's three ways you can view the service map. There's the map view, table view, and graph view. So the map view, which you're seeing in this current slide, it lays out everything in a topological format. So the core application is placed at the center with all the depending instances branching out. So this layout helps you instantly recognize bottlenecks or broken connections in your architecture. So whether you're managing a simple web application or a large microservices-based system, this visual mapping can significantly cut down on the time it takes to diagnose and troubleshoot the problems. So now let me take you into the Applications Manager UI, and I'll show you how everything that we've discussed can be set up in the APM Insight monitor. So I hope you can all still see my screen. So this is the UI of Applications Manager. So on the home page, if you navigate to the new monitor section, and if you click on Add New Monitor, you'll find a list of fully supported infrastructure monitors. So this includes monitors for cloud applications, for database systems, middleware, and of course, real user monitoring in APM Insight. So under the APM Insights section specifically, you'll notice a categorized view showing all the various technologies that are supported, just like what we saw in the earlier slides. And if you switch to the APM tab that you can see here, it gives you a focused view of all the performance monitoring that you've already set up. So it neatly lists all these monitors that are currently active. So you can quickly jump into any of them, and you can view them or edit the configurations. Now, let's say I want to add a new monitor. I'll click on this Add Monitor button here. At this point, I'll need to select the technology stack that my application is using. So in this case, I'll select a Java-based application. And here it is. This is the new and improved Add Monitor page that I mentioned earlier. So compared to the old manual process, this revamped setup is much more streamlined and user-friendly. So that helps you complete the configuration faster and with fewer steps. So now I need to choose the deployment type. So you have the option to either deploy your agent directly on a host machine or in a container. So I'm going to select the host deployment for this example. You can choose your operating system. I'm going to choose Windows. And I'm also going to choose the Java framework being Apache Tomcat. So once that's done, I'll click on Next, and I'll move on to the configuration section. So here I need to fill out a few key details. So the name of my application, the running port, and the Java version. So these are important because they help the agent communicate correctly with the Applications Manager. And I can also click on Advanced Settings. And I can also fill out the protocol, host name, the port, and even the APM Insight license key if required. But these details are usually auto-populated. So then I'll click on Next. And with all of these configuration details in place, this is the final step, command execution. So this step can also be handled automatically. And once the agent is successfully deployed, I'll click on View Monitor, and it will be added to your Applications Manager setup. So to give you a better look at this, I have a sample web application here that emulates a pet store. So I've already added it to Applications Manager. Let me just make a few transactions here so that we can see them in the product. So I'm going shopping for a pet. Let's say I want a dog. I'm going to go with the Chihuahua. I'll add it to my cart, proceed to checkout. And it's there in my cart here. So I'll just continue. I'll click on confirm and I've made this transaction. So if I go to my setup here, this is my application, my sample application. Once it's onboarded, it will be available under this applications tab. So by default, the data will be for the last 30 minutes, but you can select any time frame that you want. For example, let me go to the last 7 days. And under the overview tab, under this overview section, we're greeted with a snapshot of the key performance metrics that we discussed earlier. So here we can see the APDEX score, the average response time, the number of requests, the data throughput, and any exceptions that were logged. So by default, the data shown will be for 30 minutes, but I can adjust it for any time. So now looking at this time frame, I can see the APDEX score, and I can see the percentage of users that were satisfied and how many are tolerated. For example, it shows 97.9% of users are satisfied and only 2.1% are tolerating. We can also view the average response time. I can see that it's 38.4 milliseconds over here. You can also see how much data was transferred, how many exceptions were encountered. So all of this helps form a complete picture of the application's health. So below this, I have a very useful visualization. It's a breakdown of response time by components. So this is where we can see a timeline chart showing where the response time is being consumed, whether it's due to HTTP calls, database queries, or application code, or any external services. So I can see here that there's a very visible spike in this graph. So by hovering over it, I can immediately tell that during this time, the response time was elevated. In this instance, it seems to be due to an app code. So as an application owner or developer, this kind of insight is very important. So in large-scale applications that handle hundreds or thousands of user transactions, it's not always obvious which transaction is slowing things down for users. So that's why I'll go to the demo page for this. Yeah, so we also have a tab here called Top 5 Transactions by Response Time. So this helps us quickly identify the heaviest transaction and the ones taking the most time to process on the user end. So let's say I've spotted a transaction here that's maybe taking longer than expected. So I'll just click into that transaction to drill down further into the specifics. So it takes me to this Transactions tab. So here I can solely focus on the performance of that one transaction. So this view offers both a table view and a graph view. So on the graph, I can see the APDEX score that's associated with this transaction, and I can get a sense of its stability and responsiveness. So right now it's showing an APDEX average response time of about 1.22 seconds. That might not sound too bad, but based on the user expectations, we'll want to drill down further and investigate. So I can also see the number of requests that were made during this selected period. So now that we're looking at this particular transaction, we can go even deeper and we can view the traces that contributed to this slowness. So before that, there's a breakdown of response time by components once again. Just give me 1 second. Yeah, so here I can see the response time broken down by components. So again, by hovering over it, I can see which parts of the application are taking longer to execute. So I can see here whether it's a HTTP call, an app code, JDBC, or whatever it is. So we also have a table view, a few more scrolls below, which gives more information about request throughput, data throughput, and any other related metrics, which will give us further clarity. Now, let's say I've noticed a trace let's say I've noticed a trace here that stands out in a particular time window. I want to understand what's really going on with this delay. So I'll click into one of these traces to drill down further. So this brings us into the method level trace view, which gives detailed insights into how this particular request was processed. So here I can also expand each method call individually. If I go to the bottom, I can expand each method call and Yeah, and this level of detail is incredibly helpful when I'm trying to narrow down what needs to be optimized. So as a DevOps engineer, what I do in this scenario is I use this built-in screenshot feature, and I can take a screenshot of all of this information on my screen here, and I can send it to my to the respective teams so that they can go ahead and optimize the logic or restructure the query. So this collaborative workflow between monitoring and the development teams, it helps us maintain a smooth and responsive application experience for the end user. Now, in addition to these trace details, we can also see the specific SQL statements that were executed as a part of this transaction. So I can sort them based on response time if I want. And we can quickly identify which query is contributing the most to this delay. So similarly, if the transaction had any, if it involved any external calls, I can click on the remote calls here, and those would also show up here. So especially in a production environment where the volumes are high, these queries can take up even more execution time. So this breakdown is really useful when you need to share the problematic query with your internal teams or developers. So now if any exceptions occur during the transaction, those are also captured here. So we can head over to the exceptions tab. I can see these two exceptions over here. So by clicking on this exception class, I can view the complete stack trace. So this stack trace is critical when debugging, and we can directly pass it on to the development team. So fixing this will not only eliminate the exception, but also bring down the response time, which in turn helps improve the user experience. So it's not just this one transaction. If there are any other slow transactions also, they'll be listed here, and we can drill down. We can use the same drill down process. So for that, I'll go back to the transactions tab here. And I can view the list sorted by these different metrics. Now, if there's a critical transaction that I want to track continuously, I can mark it as a key transaction. So if I go to the build here, I can you can see I've marked one of these transactions as key. Let me just do another one. And if I go to this key tab here, I can view these transactions under this as a key transaction. So that way, instead of monitoring everything, I can focus on just the important ones and keep an eye on them in one place. So this helps with prioritization and long-term optimization. So now let's go to the database tab. So since this is a Java application, since the Java application interacts with the PostgreSQL database, we get complete visibility into all the queries that are being executed, whether it's update, insert, or delete operation. So by clicking on the all option, I can get a consolidated list of all the queries that are running in the background of this app. So to spot performance issues at the database level, I can sort the queries by response time, the minimum, maximum, total, whatever it's needed, and the average response time. And immediately I can see which specific query is taking longer to execute. So for example, I can see that this one, it's taking the longest here. I can click into it, and that will give me a more granular details. So it's showing me the how long it took, the average response time, how many times it was executed, and whether there are any related transaction traces. So this will help zero in on the real cause of the slowness. So I already talked to you about the traces tab earlier. So now let's explore the JVM tab. So since this is a Java-based application, we can monitor how the application is consuming memory and what kind of CPU usage it's hitting, the JIT compilation time, and the memory stats, like how many classes are being loaded or unloaded. So scrolling down, we can get a comprehensive breakdown of all of these JVM parameters, from the runtime memory to loaded classes to compiler metrics. And this level of detail, again, gives these teams a concrete idea of how the Java engine is performing and whether anything is causing a memory bottleneck. So there's also a dedicated exceptions tab over here. So this lets us keep track of HTTP errors. So to demonstrate this, let me demonstrate a 404 error with this pet store application. So if I just edit the URL here, it will give me a 404 error. So that would have been captured in my product. So for example, in this demo build, let me just click on this 404 error. I can click into that error and see this in more detail. So I can drill down into the specific exception class, and I can view the complete stack trace. Yeah. So I can drill down into the specific exception class and view the stack trace, which again can be shared with the developers for a faster fix. So one more helpful visualization here is the service map. So as I mentioned earlier, this gives you a visual overview of the application's connections. So by hovering over it, you can see the health status, what's the average response time, and whether any requests are failing while connecting to the database. So there's a map view, a table view, and a graph view over here. So that helps us understand these relationships even better. So we can also monitor JMX parameters under this App Parameters tab. So the default parameters are in place here, but if you want to add anything custom, you can just click on them, and and if you add anything custom, that can also be done here. So there's also a tab called the feature called thread profiling. So this lets you helps you profile Java threads on demand. So for example, I have a previously captured thread trace over here. So if I click on it, it shows which threads are currently running, which ones are taking more CPU time, and the full stack trace behind them. So I can expand these, and it shows me the complete stack trace. So it shows, yeah. So this again can be shared with the development team for immediate action. So now let's look at RUM analytics. So this brings together the front-end metrics like the APDEX score and page views with back-end APM metrics like response time and request count. So one of the most useful tools here is this global user experience chart. So it shows a geographic map of how users across these different countries are experiencing the application. And by hovering over any particular country, it gives me the APDEX score and the number of pages viewed by the users in that particular region. So this is a really useful way to pinpoint the performance issues by geography. So lastly, if I want to export all of this data, I can, let's say for a report or for a review meeting, I can just go to the transactions tab, and under this share button here, I can, under this export button, I can have the option to export it as an Excel file, as a PDF, or a CSV. Yeah, so that was a full overview of the Java application performance monitoring flow within Applications Manager. So we moved from the high-level overview and the transaction insights all the way down to traces, SQL queries, JVM metrics, exceptions, and even global user interface. So everything that you need to monitor, analyze, and optimize your application is right here. So let's have a quick recap of today's session. So firstly, when we explored tracking application performance using APDEX score by finding problems in its application code. We explored tracking these transactions from one application to another and debugging these issues, identifying problems in the code stack, and how service map makes it easier to identify these problems. So we'll also get into some of the frequently asked questions now. Before that, if you enjoyed this presentation and if you found it useful, our panelists will also share a poll, and you can rate the presenter and the presentation. So please do take a moment of your time and rate the presentation. So thank you everyone for attending this session.